Hey, ho, ho, hey! How's it going, everybody? You excited about spring break? I know we are. I'm just heading down to the beach down here at Cove Point. Maybe sit on the beach for a while, do some light reading, whatever. But you know what? Before I head down to the beach, I think I might talk to you guys for a few minutes about scientific notation. Let's see, where can I talk about that? Let's see. Oh, wait! We got a little board set up right here. Awesome. I'm going to just get my serious attitude, my serious dress now, and get to work. Okay, here we go. All right, I'm back. All right, so I noticed when I was looking at some of the work that you guys were submitting, I noticed that you guys were making the same mistakes sort of over and over. And I was having to type on my phone the same sort of corrections. And so I thought, well, let's try and show you how to do these things live and in person. So here, we're gonna try this, okay? Shoot, put on my markers. Shoot. Oh, wait, here they are. Yes, I do, good. All right, so when we multiply two numbers that are in scientific notation, most people were doing this part right. You're going to multiply the decimal numbers together. So 9.3 times 2.4. And I'm not going to do that. I'm going to do that on my calculator. I happen to have that in my pocket because I was going down to the beach. I need my calculator at the beach. And I'm going to do 9.3 times 2.4. And that part comes out to 22. That's important. 22.32. So that's 22.32 times 10 to something. Okay. And then to get to the exponent part, remember, we just do 10 to the fourth times 10 to the negative sixth. When we multiply those two numbers together, we add the exponents. Keep the base the same, add the exponents. So it's times 10 to the 4 plus negative 6. And 4 plus negative 6 is, anyone? Good, negative 2. All right. Now that's not the final answer, because we always have to leave our answer in scientific notation. Scientific notation, remember, is when you have a number between 1 and 10 here and times the power of 10. That number right there is not between 1 and 10. So I got to change it to a number between 1 and 10. Okay, the cat is hitting the... So she's causing a little bit of an earthquake. All right, so we're going to change this number to 2.232. Move that decimal one place to the left. Now, here's how you figure out if the exponent is going to get bigger or smaller. We made this number, 22.32, we made it smaller. So we got to make the exponent bigger. We made it smaller by 1 decimal place, so we're going to make the exponent bigger by 1 decimal place. Bigger than negative 2 is negative 1. So the final answer is 2.232 times 10 to the negative 1. That is the correct final answer to that problem. 2.232 times 10 to the negative 1. All right, so very similar problem occurs when we're doing the second one here. The second one clearly is division. We're going to divide 4.6 by 5.01, and then we're going to figure out the exponents. There's two things I want you to notice here. So 4.6 times 5.01, I am not going to do that one except for on the calculator. So 4.6 divided by 5.01. Okay, that comes out to 0.918. So that's 0.918 times 10 to the. All right, so now this I noticed on the assignment I was checking, the one we were doing, the example we were doing had a 0 here and a negative 6 here. And lots of people were telling me that 0 minus negative 6 was equal to negative 6. And it's not. Because when I say 0 minus negative, that minus negative cancels out and it's actually plus. So in the same exact idea here, we got negative 2 minus negative 3. That's negative 2 plus 3. And negative 2 plus 3 is just 1. Okay? However, 0.918, that's not a number between 1 and 10. So I got to change that to 9.18. And let's see, in this case, I made this decimal number greater. So I got to make this exponent less. So I got to go 1 less than 1. 1 less than 1 is 0. So that's how I would write that answer in scientific notation. Okay, those are the first two ideas I wanted to make sure we clear. Really, the big idea I wanted to clear up in this one, the big idea was when we get an answer that's not in scientific notation, we got to change it to scientific notation. And the little tiny idea I wanted to clear up from yesterday on the assignment was when you subtract this exponent minus this exponent, when you have a double negative, you got to turn it into positive, into plus. All right, so now I need you guys to remember for me. Remember when you were maybe in, like pre-algebra or something, you learned how to do problems like these two problems. And just because we're doing scientific notation now, that doesn't change the rules of math. So we're going to use the same ideas when we're doing scientific notation as we do on these. So this guy right here, 6x squared quantity cubed, that is equal to 6 cubed times x squared cubed. And 6 cubed, everybody knows, is 36 times 6, which is right 216. And then x squared cubed. Okay, that's x squared cubed. That's x to the, it's a 2 plus 3 or 2 times 3. Oh, that's power of a power. And power of a power, you multiply the exponents. So that's x to the 6th. So that's the answer to that one. 216x to the 6th. We take the first one, the 6, and we take it to the 3rd power, and then we do x squared to the 3rd power as well. So this was a little harder, but we still do the same idea. We're going to do 1/2 squared times y to the 4th squared. Okay? 1/2 squared is 1/4. And then y to the 4th squared. Now that's not y to the 16th. No, no, no. That's y to the 4 times 2. 8. Y to the 8th. So that's how you would do that one. Now we're going to use these exact same ideas to do a problem like this one. This is the scientific notation. And this is something I did not show you yesterday because I'm a slacker. I should have showed you this yesterday, but I didn't. So we're going to show it to you now because this is something I saw you guys were doing wrong. So when we do a problem like this, we're going to take that number to the -6th times that number to the -6th. So we're going to go 7.87 to the -6th times 10 to the -1 to the -6th. Now, I'm never going to be able to do 7.87 to the -6 without using my calculator. I just literally am never going to be able to do that. That's way too hard. So we're going to do that right now. And I'm going to get something that's going to be foreign to me. 7.87 to the -6. And I get this, my calculator says, can you see that? My calculator says 4.2087, blah, blah, blah. And it has an E -6. It says this, 4.2807. Is that right? Is that what I said? Oh, 4.2087. And then it says E -6. That's how the calculator says scientific notation. This is the same thing as 4.2087 times 10 to the -6. So this part is right here. But I still got to do this part. I still got to do this. Times, so now I got to figure out this. What's -1 times -6? Right, it's 6. So that's times 10 to the 6th. So that looks really confusing now. I got this 4.2087 times 10 to the -6 times 10 to the 6th. So what am I going to do with that? What's 10 to the -6th times 10 to the 6th? What do you do with those exponents? Right there. We're going to add them together because I have the same bases and I'm multiplying. What's -6 plus 6? 0, right. So this answer, this final answer is 4.2087 times 10 to the 0. And 10 to the 0 is just 1. So this final answer is just 4.287. Now that was one way to do it. Now we're going to do it a second way, just to show you get the exact same answer. Let's figure out what 7.87 times 10 to the -1st is first. Well, if I change this, if I wanted to change it to regular instead of scientific, I would just take that negative or that -1, that exponent, and that tells me to move my decimal one place to the left. And so 7.87 times 10 to the -1st, 7.87 times 10 to the -1st, all of that to the -6th, that's equal to 0.787 to the -6th. Now that's weird, 0.787 to the -6th. Let's see what we get on the old calculator. 0.787 to the -6. No way, we got 4.2087 again. 4.2087. Again, got the same thing both times. All right, so what I wanted you to get out of this example, is when you do the power of a scientific notation, generally what you do is you do the power of the decimal number times, and then you multiply the exponents for the power of 10. Now this one came out strange because it was to the -6th, and the calculator couldn't do that. Had to do it as scientific. That's why it came out strange like that. Came out strange like this. But in general, you always do the decimal number to the exponent times the power of 10. You add the exponents. All right, so I got to be getting on my way because I'm heading down to the beach. I'm going to catch up on some reading while I'm down there. One thing I'm going to make sure I read on the beach today is this book here by my friend Todd Whitaker. It's about what great teachers do differently, okay? So I'm going to try and catch up on that and find out what I can do better. Okay, well, have a great spring break, okay? Celebrate your Easter, however you're going to celebrate your Easter, and take care now.